Hey guys, so in this problem we're taking a look at Mr. Rennie, who's able to make a pizza from scratch in 1 hour and 30 minutes, and a restaurant chef that's able to do the same thing in 40 minutes. And what we're going to do is we're going to figure out how long would it take these two individuals working together to make a single pizza. So one of the ways that I approach these problems is I always organize the information into a table where the table always has the names that are involved. How long does it take each individual alone to complete the task? And if you know the alone time, you can figure out their rate of work. Now, the rate of work is important because the amount of work that somebody does is always equal to the rate that they work at times the amount of time that they spend working. So really the idea here is that if we know what the rate and the work time is, then we can figure out how much work the person is actually doing and create an equation to solve for the rest of the problem. So what I'm going to do here is I'm just going to set up our table real quick. And now that I have the table set up, I can start putting in the information that we know. We know that for Mr. Rennie, the amount of time that it takes him alone to make a single pizza is 1 hour and 30 minutes. And I'm noticing that this is using two different time units here, so I'm going to go ahead and convert this to minutes only. So in minutes only, this is going to be 60 minutes plus 30 minutes, so it takes Mr. Rennie 30 minutes to do this. And then for the chef, we know that it takes the chef only 40 minutes to make the pizza. Now taking a look at the rate. The rate is always going to be the reciprocal of the alone time. So if the alone time is 90 minutes, then the rate for Mr. Rennie is going to be 1 over 90. And for the chef, it's going to be 1 over 40. So now the question is, well, how much time do they spend working? That's what we don't know. Because we don't know how much time it would take the two people working together, that's going to be where we put the variable. Now, the reason that X gets put in both of them is because we know that Mr. Rennie and the chef are working together for the same amount of time. If one of them was working longer, you would have to put X in one of the work times and then put X plus something in the longer person's time. So that's something to keep in mind for later on, but for this problem, we're just going to use X right here. Now, using the idea that we see right here in red, the rate, which is 1 over 90, times the work time is going to mean that we get 1 over 90 times X, which we can see is just going to turn into X over 90. Now, when we do the same thing down here on the bottom, it's going to be 1 over 40 times X. It's going to turn into X over 40. So now that I know the amount of work that's actually been done, what I can do is I can start to set up my equation. Now, in all of these types of equations where you're dealing with work, the basic idea is that the work done by person 1 plus the work that's done by person 2, and then if there's any other people, you would just keep adding the amount of work that they're doing, should all come out to be equal to the number 1. And this number 1 is basically just the number of jobs that are being completed here. So that idea is going to basically turn into, well, the amount of work that Mr. Rennie is doing is this X over 90. So X over 90 plus this X over 40 is going to equal 1. So then the question becomes, okay, how do we solve this? Well, a strategy to get rid of fractions, if you don't like dealing with fractions, is to just pick one of the fractions to get rid of. And I'm going to focus on getting rid of the 90 right here. So I'm going to aim to get rid of this 90 by saying if I take that 90 and multiply every single term of this equation by 90, then that's going to ultimately get rid of that one fraction. So what's going to happen here is this 90, and the highlighted 90 will cross out and we're just left with x. Now multiplication moves into the top of a fraction, so this is going to turn into 90x over 40 equals 1 times 90, which is now 90. Now taking a look at my next step, I want to get rid of this 40 that I see right here in green. So I'm going to do the exact same idea, is I'm going to multiply every single term of the equation by 40. So multiply this by 40, multiply this by 40, multiply that by 40, and again, the 40s will just cross right out. So now I'm going to be left with 40x plus 90x is equal to 3,600. And now I can see what I have here is a much simpler equation. So taking a look here, the 40x plus 90x is going to give me 130x is equal to 3,600. So now taking a look here, I can see that I need to divide by 130 on this side, which means I need to divide by 130 on this side. And grabbing my calculator here, these are going to possibly have large numbers, so definitely have a calculator handy. I get that this is about 27.69, and we'll take a look at what that means here in a moment, but again, 69. Okay, so now you know that x is 27.69. Go back up to the table and take a look at where x was. X was the work time. So x, we just found out, was 27.69. So 27.69 for both of these parts of the table. Now, if I had to write this in a sentence, what I would do is I would say, okay, I wouldn't walk up to someone and say it takes them 27.69. I would say it takes 27 minutes, and then to get how many seconds it might take, I could say, okay, well, this 0.96, or 0.69 rather, is 0.69 of a minute. Well, a minute is also 60 seconds. So if you really wanted to get super accurate here, you would just say 0.69 times 60, and that would give you 41 on the calculator. And so we can say 27 minutes and 41 seconds for the entire problem. One of the things to note about this is that the reason I knew to use minutes is because when I take a look at the table, we converted all of our times into minutes right here in the alone time. So because all of our time is measured in minutes, our work time has to have the same unit of measurement. If we had used hours right here, then all of our work time would have had hours involved.